Hello everyone, welcome to my ninth video lecture on infinite series. In this video, we will consider further examples on ratio test. So here, the first example is to discuss the convergence of the series summation of n factorial divided by n to the power n. So it is very easy here. So the given series is, if we consider the given series as summation un, here un, we observe the given series. In the given series, the nth term is directly visible, so that nth term is un we are considering here, and let us write down the value of that. It is n factorial divided by n to the power n. So this is the nth term of the given series of positive terms. After having un, in order to apply the ratio test, it is advised to go for the next un plus 1th term. So how to get? Simply by replacing n by n plus 1 in the un term. So in un, replace n by n plus 1 to get the un plus 1th term. So here in place of n plus 1. In the power, in the exponent position also, it is n plus 1. So we are having this thing over here. Now consider un plus 1 divided by un. So that is equal to, so let us write down un plus 1 in the numerator. That is, directly we shall keep it as it is. So that is n plus 1 factorial divided by n plus 1 whole to the power n plus 1. We kept un plus 1 as it is because it appears in the numerator, and un is appearing in the denominator. Therefore, let us write its value in the form of reciprocal directly in the numerator. So now we have to simplify this by considering the group of similar terms together. So first let us take the factorial terms. So it is n plus 1 factorial divided by n factorial we have taken together, and here n to the power n divided by n plus 1 whole to the power n plus 1. Let us keep it as it is right now. So we have kept it like this. Now this is equal to, again n plus 1 factorial can be written as n plus 1 into n factorial, because one can write 4 factorial as 4 into 3 factorial, or 4 into 3 into 2 factorial, or 4 into 3 into 2 into 1. So that is the traditional way of writing the factorial. So by using that property, n plus 1 factorial is n plus 1 into 1 less, that is n factorial divided by n factorial as it is, into this is n to the power n divided by n plus 1 whole to the power n plus 1 can be written as n plus 1 to the power n into n plus 1. So bases are same. When we add the indices, we get this thing again. So this thing has been expressed like the two terms by using the property of indices. Now this factorial cancels. This bracket n plus 1 cancels with this bracket n plus 1. So the remaining thing is n to the power n divided by n plus 1 to the power n. Or we can write it as n divided by n plus 1 whole to the power n. We can write like this. Now, according to ratio test, we have to apply limit as n tending towards infinity. So limit as n tending towards infinity of un plus 1 divided by un equals to, on the right hand side, this is the term. So limit as n tending towards infinity of, let us keep this as it is, n divided by n plus 1 whole to the power n. Now we have to apply the limit and we have to simplify this. So this is equal to limit as n tending towards infinity of In the numerator keep n as it is, whereas in the denominator take n outside. So whenever we are advised to go for evaluation of limit, we do this type of job. We take n outside. When we take n outside here, here it is remaining 1 plus here it is remaining 1 by n. So it is whole to the power n as it is. In the next step, we can cancel this n with this n. So the remaining thing is 1 to the power n is 1. So let us write limit as n tending towards infinity of, in the numerator it is 1 n by n cancelled, 1 remains, 1 to the power of n is 1, divided by, it is 1 plus 1 by n to the power n. Now this is, when we apply the limit on this is one of the standard limits and its value is 1 numerator as it is. The value of this by using one of the standard formulae, it is e, where e is approximately equal to, it is an irrational number whose value is 2.71828 ... like that. So numerator is 1, denominator is 2 point something, so numerator is less than the denominator. So the total answer, that is the answer of this limit as n tending towards infinity of un plus 1 divided by un, the total answer what we are getting, it is less than 1. When it is less than 1, by the so-called ratio test, what we are using, the ratio test we are using, by ratio test, the given series summation un is convergent. So this is the solution of the first problem. Consider the second example. Here we have to find the nature of the series 4 by 3 plus 4 into 7 by 3 into 5, 4 into 7 into 10 divided by 3 into 5 into 7 plus ... So what we are observing, the terms in the numerator or the factors in the numerator are increasing. In the first term, there is only one factor in the numerator and in the denominator. In the second term, there are two factors in the numerator and also in the denominator. In the third term, there are 3 factors in the numerator and 3 factors in the denominator. Therefore, in the general term, that is in un, we will be having n number of terms in the numerator and n number of terms in the denominator. So here if we write the terms systematically and observe that 4 which is present in the first term, it is carried to second term also and third term also. 7 which is present in the second term is carried to third term also and in the further terms also. Therefore each term is carried forward. Therefore when we go for writing the nth term, we should start with the first, that is 4. The first factor is 4, the second factor is 7, the third factor is 10 ... and what should be the last factor? The last factor, that is the nth factor, is 3n plus 1. We observe here, in the first term it is 4. We can write it as 3 plus 1. It is in the second term 4 kept as it is. The next factor is 7. 7 is 6 plus 1. 6 can be written as 3 into 2 plus 1. So it is 3n plus 1. n equal to 2. And for the third term, 4, 7 kept as they are. The last term is 10, and 10 can be written as 9 plus 1. So 9 is 3 into 3 plus 1. So it is 3n plus 1, n equal to 3. So like that, in general, in the nth term, it should be 3n plus 1. And similarly, what should be there in the denominator? Start with 3. So look at the terms, they are the odd numbers, 3, 5, 7. So they are the odd numbers, and we know that odd number representation is either like 2n plus 1 or 2n minus 1. So here we should take 2n plus 1 because the first term is 3. So when n is equal to 1, 2n plus 1 gives us 3. So it is 2 plus 1, it is 4 plus 1, 5, the second term. In the second term, we have to put n equal to 2. Therefore, it is 2 into 2. 2 into 2, 4 plus 1, 5. We are getting the second factor which is present in the second term. Similarly, this is 6 plus 1. So it is 2 into 3 plus 1. So 2n plus 1, n equal to 3 in the third term. So we are getting the factors like this. In general, the nth factor in the nth term is 2n plus 1. So this is how we have written unth term. By looking at this, now our duty is to write what is un plus 1. So un plus 1 usually we write simply by replacing n by n plus 1 in the nth term, that is un. But we are observing here in each term the factors of the previous term are appearing. Therefore, in un plus 1th term also, the factors of un should appear. Therefore, we should keep all the terms which are present in un as they are. So it is 3 into 5 into 7 into dot 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 into 2n plus 1. First we should keep all the we should keep all the factors which are present in the previous term as they are, and then we have to replace n by n plus 1. So when we replace n by n plus 1, it is going to be 3 into bracket 3n plus 1. So we can write 3 into bracket n plus 1 plus 1 as it is. So we can use this type of bracket here. Divided by, here also 2 into, in place of n we are advised to write n plus 1, this plus 1 as it is. So this is un plus 1th term and this is unth term. Let us consider un plus 1 divided by un. This implies when we consider the ratio, that is un plus 1 divided by un. So first we are advised to write this term as it is. Sorry, that is n plus 1th term as it is. That is 4 into 7 into 10 into dot 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 into 3n plus 1 into, let us simplify this, 3n plus 3 plus 1. So it is 3n plus 4. The simplified form. In the numerator we have written the last factor also together with the earlier factors. So here it is 3 into 5 into 7 into dot 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 into 2n plus 1 as it is, into, this is 2n plus 2 into 1 2, 2n plus 2 plus 1, it is 3. So this is un plus 1 we have written as it is. Now we are advised to write un in the denominator. Instead of writing un in the denominator, we can write the reciprocal of un in the numerator. Therefore, it is 3 into 5 into 7 into dot 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 into 2n plus 1. The numerator first we have written, that is the denominator of un we have written in the position of numerator, and the reciprocal, therefore 4 into 7 into 10, it comes to the denominator. So at the end, this much. Now let us cancel these terms. We are observing one beautiful thing over here, that is all the terms from here to up to 3n plus 1 cancels with these, and these terms all will cancel with these terms. So only remaining terms are 3n plus 4 in the numerator, 2n plus 3 in the denominator. So this is the only thing remaining after cancellation. So 3n plus 1 sorry 3n plus 4 divided by 2n plus 3. Now our duty is to take limit as n tending towards infinity of un plus 1 divided by un equals to, on RHS also it is advised to take the limit. So numerator is 3n plus 4 divided by 2n plus 3. So we are applying the limit. We cannot directly apply because it takes infinity by infinity form. Therefore, we are advised to simplify by taking n outside in the numerator and also in the denominator. When we take n outside here in the bracket, it is 3 plus here it is 4 by n because we are taking n outside divided by here when we take n outside it is 2 here plus 3 by n here. Now this n cancels with this n. In the remaining thing, if we put n equal to infinity here, so the final answer is 3 plus 0. 4 by infinity is infinity. 4 by infinity is 0. Therefore, it is 0 divided by 2 plus 3 by infinity is again 0. So it is 2 by 2 plus 0. So the answer is 3 by 2 whose value is 1.5. Numerator is bigger, denominator is smaller. Of course, the answer is greater than 1. The answer is greater than 1. 3 by 2 is 1.5 of course. Therefore, it is greater than 1. Therefore, conclusion, by ratio test, the given series summation un is divergent. So this completes the solution of second problem. Thank you very much.